From the studios of KENW on the campus of Eastern New Mexico University, it's You Should Know, featuring the people and events of Eastern New Mexico and West Texas.
Welcome. Thank you for joining us for You Should Know. My name's Evelyn Ledbetter, and I'm hosting today. Our guest today, we have Dr. Drew Davis. He is a professor here at Eastern New Mexico University in the Department of Biology. And we also have Josh Gonzalez, who's one of our students and is a senior and graduates this semester. And he's wildlife and fishery major. So thank you for joining me.
Thanks for having us, Evelyn.
Yeah, nice to have you guys. So this is a lot out of my wheelhouse. So I'm going to ask lots of questions that you can laugh about. So tell me a little bit about yourself, Dr. Davis.
Sure. Yeah, I'm an assistant professor of wildlife biology in the biology department here at Eastern, and I started this last year. And mostly I research herpetology, so that's the study of reptiles and amphibians. And today we're going to be talking about one of the projects Josh has been working on in my lab.
Okay. And Josh, tell us a little bit about you.
So I'm a student here at Eastern New Mexico University, a wildlife and fisheries major, and I started working in Dr. Davis's lab. And so today I'll just be kind of talking to you about the research I've been doing with the smooth softshell turtle.
Okay, great. And I know y'all are both really passionate about this, so this will be fun. So tell me this, how the concept of the research came about.
Yeah, so I moved to Portales and was looking at potential research projects and areas where we simply didn't know a lot about a particular species of reptile and amphibian, and things that were kind of within the area, within the region. And a big one was this question about smooth softshell. So it's a species of turtle that is in the Canadian River, just a few hours north of us. But we simply didn't know a lot about it, and there hadn't been any recent work done with it. So it seemed like an opportunity to help generate information and better understand the species.
Okay. And I know you mentioned also the logistics of having something you could study that is within a distance.
Yeah, that definitely helps being close, right? Rather than, we're on the eastern edge rather than having to go all the way to the other side of the state.
Okay. So. And so with Josh, how did you start working with Dr. Davis on this?
So I had him for one of my classes, and I heard he was a herpetologist, so I got really excited because I already had a background in working with turtles, with box turtles and another type of turtle in the river, in the Black River. And so the second I heard about potential turtle research, I jumped on it super quick. And
Your hand was the first one in the air.
Yes, I definitely.
Take me.
Yes. I emailed him and I approached him rather quickly, and almost within a week we got some, it's called like a research grant.
Okay.
And so it's more like a scholarship kind of, but within like a week or two, we ended up getting that submitted, and that's kind of where it first started to start the research on this turtle.
Okay. All right. And you did the study. So just kind of walk me through what the goals of the study or what you were looking to prove or disprove, and what the research method was that you did.
A lot of it was kind of just species detection at first, because we didn't even know if this species would be in the Canadian River in Eastern New Mexico. So it was just kind of like glassing and with binoculars, looking for this turtle, setting up traps for this turtle. Then we did another method called eDNA, which is environmental DNA. I can get into that later. But it was just trying to fill in this gap of knowledge, several decades long, right? Mm-hmm. Yeah, several decade-long gap of knowledge for this turtle.
Okay. And so, and the research was off the Canadian River, correct?
Yes.
Or in that area.
Mm-hmm.
That area. So that's basically around Logan here in New Mexico.
Right. That's where we primarily trapped. And hopefully, further down the road, we can trap more, maybe northern New Mexico, or just kind of keep following up that river.
Okay. Well, do you want to, so the smooth shelled turtle is the one that we're looking at today versus the spiny, right?
Well, actually, the one we have here today is a spiny softshell turtle, but our research is for the smooth softshell turtle. Unfortunately, we didn't have a specimen on hand for the smooth softshell, but they're pretty similar.
Okay. Well, what kind of show us this? Does this guy have a name?
He doesn't have a name.
Unlucky.
He's got a number.
He does have a number.
He has a number. Okay. Well, tell us a little bit about the spiny guy and kind of maybe talk about the similarities to the smooth.
Yeah,
and
definitely.
talk
So
about that.
they're both soft shell turtles. The cool thing about this one is you can see kind of like all the bumps that go along here. That's what makes it a spiny soft shell kind
Okay.
of. There's some other differences. The nose is also a difference. Am I missing anything? What else is a difference?
No, mainly it's, spinies are covered with these, kind of fleshy spines that can be tough to see from far away. So really getting one up close is a good way to tell them apart. But they're very similar in their appearance with their fleshy, leathery shell.
Yeah,
that
it's
they
got
have,
a definite.
And this one's a preserved specimen, so he's not as pliable as they would be otherwise. But there's just you can't. If you look at the shell, it's much different from what most people would think of if they think of a turtle in the water, right? It's got a hard, bony shell. There are bony elements, but they're much reduced, and so it leaves a lot of this shell. And what we think about the shell is sort of just being absent of bone, and it's this sort of thickened, leathery shell that's in its place.
Right, and whenever you look here on the back side also, you can see that there's no protection or anything really, that there's
so
just
that
a lot
guy-
of
There's, I
of
mean,
lack
like a
thereof
box turtle
bone.
has that hard shell on the
Correct.
underneath side, right?
Mhm.
So,
Right.
so an animal, a predator, if he tries to eat or something, they
Mhm.
can get to him. But this guy, there's nothing there to protect him. Not much. This right here, right?
Yeah.
Yeah. So I mean, you can kind of see their shape, how they're almost flat. But it just kind of allows them to be much quicker in the water. It also allows them to kind of swim faster because they're more carnivorous, I would say. They kind of eat more fish and things like that. So that extra huge bone shell essentially
Slows them down.
it
Slows
doesn't
them
slow them
down.
down.
Mhm.
But
And just the weight of
yeah.
it, not
Yeah,
near
exactly.
not near as much of.
Yeah.
And I guess their feet. I've never looked at a turtle's feet, but more of little fins to help with the swimming.
Exactly. Yeah,
Yes.
they're webbed.
Okay.
A lot of webbing because these are highly aquatic. Rarely see them out of the water. You'll see them basking on sandbars and things like that. But box turtles, of course, are very terrestrial. We'll see them, in our yards and walking across roads. But really, the only time these turtles are out of the water is to nest. So females coming up on shore to nest, to dig a nest. Males will disperse a little bit, but generally they're pretty closely tied to an aquatic environment.
Okay. So what makes the Canadian area? What attracts the smooth shell to that?
Historically, the Canadian River was a dynamic river. There are still large sections of it that it is. It has a lot of sand, right? So the sandy rivers are sort of preferred by the species because what they'll do in a free flowing segment of the river is that they'll bury down into the sand to avoid predators. They have a very long neck and a kind of snorkel like nose, and so they can just stick that up and take a breath of air, but stay submerged within the sand. And they use those sandbars that are part of this river to nest on, to dig their nests, to bask, to soak up some sun, and so the Canadian checks all those boxes.
Okay.
And it connects to other rivers further to the east, where the species is a little bit more prevalent.
Okay.
Right.
So and also the water, that's where they basically they don't hibernate, but they do.
Yeah.
Go down
So they'll dig down. They're not freeze tolerant, so if they froze, they would die. Most reptiles are that way, and so they avoid freezing temperatures, and so they can do that by digging down into the mud and sediments at the bottom of a lake or a deeper section of the river, and really they just simply slow their metabolism such that they don't need to breathe and they're not feeding, so they just kind of are just in a state of almost stasis where they're underneath the mud, just waiting for the temperatures to warm up again and activity to start increasing. These are cold-blooded, so the temperature of the water does influence their activity.
And like you said, they lay their eggs. So
Yes.
and so they lay them and walk away, basically.
Yeah, so
or waddle away.
there's really no parental care once they lay the eggs. One of their biggest predators are raccoons because they will dig up their eggs and eat them. It's like that for a lot of turtles. But these guys, there's no parental care. So whenever they dig that hole and lay the eggs and they come out hatching. They're just kind of hardwired to start living on their own, and they kind of know what to do.
Isn't that amazing?
Yes.
Compared to humans, we're dead meat, or most any other species, but some of them where they just get a kickstart on their own and figure it out. So when did your research start? Is it a summertime is that when you do the study?
Yeah, so like we were saying earlier, whenever their metabolisms slow down, they're not going to go out looking for food or anything of the sort. So trapping for them or trying to do visual surveys, you're not going to see as much compared to warmer times of the year. My last trap date I did, like trap dates usually run anywhere from like May to like October, I would say. So around those times is whenever you go out and you go trapping, and it's just when you get the most activity out of these turtles.
So doing this research, how much time did you spend in that area looking and recording and documenting the turtles?
So I had multiple sites, and at each site I would set out probably, I think it was 3 traps that I would set out, and I would let those sit out for 3 days.
Can you kind of describe your traps of what you used?
Yeah, definitely. So the traps, they kind of have 3 different like hoops, I guess you could say. And so those hoops, they have a mouth end and then a closed end. So that mouth end, you kind of just leave that open towards the water, so that way they kind of get the scent. They're held up with like 2 rebar stakes.
Right, just to stabilize them so they stay put there in the water.
Right, and they have like a netting kind of, and then I have a pool noodle floaty kind of, so that way the turtles don't drown or anything like that. And then we bait them with sardines.
Okay, I was going to ask what entices them to go hang out in that little abode.
Yeah, the scent of sardines is definitely something that will catch their attention, I guess. But like I said, we have yet to actually catch a smooth softshell. We just had visual identifications, but hopefully maybe later down the road we can try changing the bait or something like that
to try to bring those in. So tell me about this. How do you know that since you didn't catch one, how do you know that they exist there? How do you know they're there?
So I did actually see.
Well, you said visual, right?
I did have 2 visual observations, and we saw a large female. And so the cool thing about these turtles is it's called like sexual dimorphism. So they are sexually dimorphic, but
which means what?
Which means that the males and females, they look different. They have phenotypical differences.
Okay.
So just things that you can observe, they look different. So the big ones, the females will be much larger than the males, and so the males are kind of around this size. It's like an average, good size adult male. But the females will get quite a bit larger. But what kind of let us know that it wasn't a spiny softshell is because we didn't see these kind of spines in the tubercles appear kind of. And on a large adult female for a spiny, those would be more prominent and you would see those more.
Because I would think if you're doing a visual, whether they're on the sandbar or they're swimming, it would be real hard to determine which it is. They're very similar.
You can, yeah, for sure. They're very similar in appearance. I mean, in hand, you can see these characters very closely, but especially, it's when they're smaller, they're more similar in appearance, but it's definitely as they get to this adult size, which is what we saw. Had 2 observations of adult females, and we had some good observations. She didn't just slide in and disappear, right? We were able to observe her for quite some time and take a lot of photos. And so these fleshy spines that would appear behind the neck here were absent on this individual we were observing. So that leads us to believe that feel pretty good that this was smooth soft shells that we were observing.
And you had one more mechanism. Do you want to talk about that?
Yeah, our other mechanism, it's called eDNA, which is environmental DNA. So that's just DNA shed into the environment from these turtles. So it could be like, skin, feces, or anything of that nature. And what we do with that is we go out and we collect water from the place that we're sampling, I guess. The
environment or whatever the location is.
Right. So we collect water from there. And with that water, we go kind of up short, and then we have this piece of equipment, and we put a filter in, and then we essentially pump like a liter of water through that, and then we store that in a liquid called DNazole, and then that kind of preserves DNA, and then you can run it through different tests to see if it's there essentially.
Okay. Okay. So, and you're collecting the eDNA through that filter is what's gathering that information, right? So then you send that back to a lab.
Correct. Yeah. The eDNA is collected on a little cellulose filter, paper filter, and it's porous, so it allows water to pass through. And it's roughly the size. The pores are about the size of the pores in a coffee filter.
Okay.
So it catches, cellular DNA and kind of gunk, and just sort of, DNA is caught on this filter. And yeah, we can take it back to the lab, and yeah, like Josh said, extract it and amplify it and look for just the DNA of just the one species we're after, in this case, the smooth soft shell. And so it's a very sensitive assay. It's very powerful. And so, right, even, it feels like you're looking for, a needle in a haystack, and the DNA is breaking down in the environment, so it doesn't last forever. But it's a very sensitive and very powerful assay that's becoming increasingly common in wildlife surveys.
And I think you had talked about you flushed the system first, right? You cleaned it to make sure there's no residual from prior
Right.
testing.
Right. So whenever I first get the equipment, I spray it down with like a bleach water solution just to kill like any potential DNA that could be there from another site that we pulled. And then I use, it's called like sodium thiosulfate. It's kind of like a saltwater mixture, but what that does is it just kind of neutralizes the bleach, so it's not breaking down stuff anymore. And I just rinse it off with water. And then my first thing I do actually when I get there to ensure that there's no false positives is I run a blink test of like distilled water. And then we also test that for soft shell DNA. So we know if distilled water pops up with a positive for soft shell DNA that something's gone wrong.
Okay, where you've got that false positive in there at that time.
Right.
So maybe
distilled
another
water
cleaning or
shouldn't
something
have,
like that and run through it.
Right. So we know that distilled water shouldn't have soft shells in it.
No, something's off on that one if it works. So, and then what did you do with your research? I mean, how many days in that area did you go through the summer? What did you say?
I think it was around 14, 15 days in total that I was up there.
And you just camped out?
Yes, I did camp out in a tent and all that fun stuff. You know?
Yeah, but you love that.
Yeah.
So, okay. And so tell me what your day would typically be when you did one of your days of research.
So like the first day when we get there, we go out and I would go take water samples. Well, actually the first thing I did, I would do visual surveys for like 15 minutes. So that's actually how we spotted the two smooth soft shells in the first place, is just doing visual surveys. And I just kind of counted all the turtles I saw. The turtle we observed and caught the most was Trachemy scripta, which I'm trying to think of the common name, is a red ear slider.
Oh, okay.
Pond slider. So that was pretty cool to see a lot of those, which they're more of a generalist species, so they're going to be like in a lot of different water systems all over the place. But no, it did allow me to see the smooth softshell turtle. And after that, I would go down into the river, and then we would pull DNA. So that's where I collect the water, like I said. And then, go out there, set traps in areas like, oh, I think this might be like, it's a little more muddy or something, right? Because, I mean, that's what they kind of hide in. It's like their biology. They like muddy, murky sandbars type of deal. So places that look like they would hang out, And then you just kind of leave those for 3 days, and then you leave that for 24 hours or close to it. Come back the next day, pick up those traps, process those turtles, take all their measurements, their weights, you mark the turtles. That way we know if we get them later for recapture. And then you just let the turtles go.
Okay. Dr. Davis, tell me about the marking on those, how you track them.
Sure. So the shell morphology of soft shells is much different from most other turtles. So with the red-eared sliders, which is the bulk of what we were catching, they have a bony shell, and we can make little notches, and they correspond with a numbering scheme. So we can read those notches and the sort of the margin of the shell that corresponds with a number. Oh, that's number 152, right? And so we can track that individual and see how it's grown or where we caught it last or things like that. Now with the soft shells, though, right, they don't have that shell morphology, that shell shape and structure. And so we have to actually insert a pit tag into these. So a pit tag is a small sort of microchip. It's about the size of a grain of rice. If you have your dogs and cats microchipped, it's the same technology behind that. So it's this little sort of injection and implant we put in the thigh. And so, right, if we recapture these individuals, we can take a little device, a little barcode reader device, and scan it over them, and it comes back with the number. So that's how we would uniquely identify soft shells, because again, we can't notch them in the same way as we could with the red-eared sliders.
Do they move quite a bit? I mean, they're so, I guess, swimming. They move in that area of water. And any idea, like the range of where how much they may change locations?
They can. I mean, sometimes females actually have a pretty amazing nest site fidelity. So even though they can disperse, long distances up and down river. Of course, dams or impediments or weir, can interfere with that a bit. But yeah, they actually have an amazing site fidelity, so they'll return to the same nesting sites often year after year.
Lifespan?
A long time. I mean, an adult turtle can live a long time. Not a lot of the babies make it to adulthood, but adult turtles can live for several decades for sure. Absolutely. Because
they're literally linked to some of the earlier creatures that we've found, right?
They've been around a very long time, yeah. So they are successful.
They've been survivors for quite a while.
Yeah.
And that is amazing, where they just pop out of that or work their way out of that shell and come about. So tell me what your research, you know that they're in that Canadian River area. So the predators that they have to, you said that it's more the eggs, more the predatory type.
Right. When they're smaller, they're going to be a lot more vulnerable. And I would say one of their biggest predators are like raccoons, skunks, badgers, or just things that are going to dig up their nest sites and kind of eat them while they're still in the egg before they even get the chance to hatch. But I mean, this research has been great. It's allowed me to go on to different conferences and to present, like essentially what I'm telling you here.
Right. I mean, to show and I know we had talked about this a little bit. If you're in your last semester and graduate within a few weeks, so tell me, do you hope what will happen with this research once you graduate?
Once I graduate, I really hope that someone kind of takes on and carries the torch. Maybe they can try different methods or something different to try to catch a smooth soft shell, because I've been unsuccessful in catching one.
Right.
So I do hope someone's successful.
When somebody else grabs that
Jealous and also ecstatic, and I'll be really happy that someone actually has it in hand now.
Okay.
But yeah, just being able to figure out if this turtle's there in the Canadian River or just something like that. This research has just been a blast.
Okay. And I know you said that part of the funding on this, you've received scholarships here through Eastern that helped with some of the research work you did this summer. And also, tell me the other program. It was through New Mexico
It's called
State,
New Mexico
right?
AMP. It's a program through New Mexico State University, and they gave me a lot of research money and funding to kind of go out there and to study this turtle. So I did get to go out there and present my research at their science conference, and I presented my research here at Eastern New Mexico's SRCC, I believe it's called. And yeah, it was just a blast. It was an honor just to present.
And then hopefully some publications and things like that will come from this.
Certainly, yeah. I mean, more time, right? So just more effort and to generate detections. But yeah, certainly the data we hope to publish.
So I don't mean to put you on the spot. Were you happy with the results? I mean,
absolutely, yeah. I mean, seeing those two individuals, of course, not trapping any, but yeah, no, that gives us hope that we can get them in a trap and that they are still there. And so hopefully, yeah, with more time, we can get more numbers and a better estimate of how many there are and how they're doing.
Josh, I can actually see you continuing to do some of this on your own personal time just to go and see what's going on.
Definitely, and I'm just grateful to be here and talk about it and share the information.
Well, and when you have a passion for something and you share that, how great is that? And I know school kids and people like that will love that. And you know, hopefully they can watch this show and learn a few things and go to school and talk about that as well. So
Definitely.
well, Dr. Davis and Josh, it's been a pleasure having you here. I always learn a lot. I did a lot of reading because I promise I've never paid much attention to turtles, but
Well,
you made me curious.
Thank you for having us.
Definitely.
thanks.
Yeah, I look forward to having you on another time.
I look forward to it.
And to all of you out there, thank you for watching, and we will see you next time on You Should Know. Cheers.